It's fascinating to consider the most distant human-made object from Earth, a title that belongs to the remarkable spacecraft Voyager 1. Imagine a probe billions of miles away behaving strangely and transmitting mysterious messages. What could be causing these baffling errors in deep space? Voyager 1's incredible journey began on September 5, 1977. At that time, Star Wars had just premiered, and at Cape Canaveral, NASA was preparing for something extraordinary. The launch of Voyager 1, a spacecraft set to revolutionize our understanding of the solar system. The mission's goal was to study Jupiter, Saturn, their moons, and the surrounding space environment. NASA knew this was a unique chance to explore multiple planets in a single mission and seize the opportunity. Voyager 1 was initially designed for a 4-year mission, but against all odds, it's still out there over 40 years later, continuing to send back valuable data. Building something so advanced in the 1970s was no small feat. Using the best technology of the time, scientists equipped it with specialized scientific instruments, each with a distinct purpose. A key element of Voyager 1's mission was its trajectory, designed to take advantage of a rare planetary alignment that occurs once every 175 years. This alignment allowed Voyager 1 to use the gravity of each planet as a slingshot, conserving fuel and increasing its speed. As it passed by Jupiter, Voyager 1 sent back stunning images of the planet's swirling atmosphere and faint rings. But the biggest surprise came when it discovered active volcanoes on Io, one of Jupiter's moons, the first time volcanic activity was observed beyond Earth. Voyager 1 didn't stop there. Upon reaching Saturn, it captured breathtaking images of the planet's rings, revealing intricate details never seen before. It also discovered that Titan, Saturn's largest moon, had a dense atmosphere, sparking excitement about the potential for extraterrestrial life. After completing its planetary tour, Voyager 1 kept going. In 2012, it achieved a monumental milestone, becoming the first human-made object to enter interstellar space, leaving the solar system and venturing into the vast unknown between stars. How has Voyager 1 managed to keep going for so long? Instead of relying on solar panels, which would be ineffective so far from the sun, it uses radioisotope thermoelectric generators, RTGs, which act like nuclear batteries to stay powered. It communicates with Earth using a high-gain antenna, allowing it to send messages across the vast distances of space. Remarkably, Voyager 1 still has functioning scientific instruments, including a cosmic ray subsystem for measuring high-energy particles, a magnetometer for tracking magnetic fields, and other tools to study the environment in deep space. Over 4 decades, it has endured solar radiation, extreme cold, and space hazards, a testament to the engineering marvel that is Voyager 1. In 2022, after 45 years of smooth operation, NASA engineers noticed something unusual with Voyager 1. The spacecraft, which had operated reliably since its launch in 1977, suddenly began sending back puzzling, garbled data. To put it in perspective, it was like receiving scrambled text messages from a friend. Imagine expecting a regular conversation, only to get a mix of random emojis. Voyager 1 was sending data that didn't make sense, an unsettling issue for a spacecraft intended to be humanity's eyes and ears in the vast stretches of interstellar space. Given Voyager 1's legendary status as one of NASA's longest-running missions, this anomaly was a major concern. At more than 14.5 billion miles from Earth, any disruption in Voyager 1's ability to transmit accurate data could signal the end of one of humanity's most remarkable exploratory missions. NASA engineers quickly began investigating the root cause of these garbled messages. Despite Voyager 1's incredible durability over the decades, its onboard systems, while robust, are now quite outdated by modern standards. Despite the challenges of the rocket's age and distance from Earth, NASA managed to resolve issues on Explorer 1, allowing it to continue its mission of probing the outer reaches of space. Although the problem was resolved, questions remain. Why did Explorer 1 unexpectedly switch computers, and could it happen again? The mission team closely monitors the spacecraft to prevent recurrence. So, what might have caused Explorer 1's errors? One hypothesis is that the harsh conditions of interstellar space, with its intense radiation and magnetic fields, are disrupting the rocket systems. Built in the 1970s, Explorer 1's ongoing functionality in such a hostile environment is remarkable. Another possibility involves cosmic rays, high-energy particles that bombard space, potentially interfering with Explorer 1's hardware. Some even speculate that interstellar dust could be a factor, though this is less likely. Naturally, there are also more outlandish theories. Some wonder if Explorer 1 might have encountered alien technology or an attempt at extraterrestrial communication. While this idea is intriguing, no solid evidence supports it. What if Explorer 1 stumbled upon something truly extraordinary? Regardless of these recent glitches, Explorer 1 remains operational and is expected to continue until at least 2025. With its power supply gradually depleting, scientists prioritize essential instruments to extend its data transmissions as long as possible. Even when its systems finally shut down, Explorer 1 will continue its journey across the cosmos, carrying the renowned Golden Record, a message from humanity to the universe. Who knows what future civilizations might uncover from this cosmic time capsule? Explorer 1's mission has greatly expanded our knowledge of the solar system and the vast unknown beyond. It is a testament to human ingenuity, curiosity, and the drive to explore. The occasional errors in its operation are just another chapter in the spacecraft's epic journey through the final frontier. Explorer 1's Odyssey is a remarkable engineering and exploration feat, reflecting humanity's ambition to push the limits of knowledge and technology. Its success is measured not only by the distance it has traveled but also by the groundbreaking discoveries it has made and the challenges it has overcome. A major contribution of the Explorer 1 mission is its role in deepening our understanding of the outer reaches of the solar system. Beyond encounters with Jupiter and Saturn, Explorer 1 has provided scientists with critical data about the heliosphere, the vast bubble of solar wind and magnetic fields surrounding our solar system. By venturing beyond this boundary, Explorer 1 offers valuable insights into the behavior of cosmic rays and the structure of our galaxy. The longevity of the spacecraft attests to the durability of its design and the creativity of its engineers. Built to withstand the harsh conditions of space for a limited period, it has far exceeded its expected operational life. This achievement underscores the resilience of 1970s technology and the meticulous planning that went into ensuring Explorer 1's reliability. The spacecraft's engineering has proven remarkably robust, managing to keep its systems functional even under the extreme conditions of deep space. The Golden Record on Explorer 1 is another captivating aspect of its mission. This disk, containing sounds and images from Earth, was designed as a message to potential extraterrestrial civilizations. It reflects the optimism and curiosity of the era in which Explorer 1 was launched, offering a snapshot of human culture and life's diversity on our planet. Intended as a time capsule, the Golden Record preserves a piece of humanity's legacy for future explorers. As Explorer 1 ventures through interstellar space, it faces numerous obstacles, including varying levels of radiation and cosmic particles that could disrupt its instruments and communication systems. Despite these hurdles, it remains a beacon of scientific inquiry, sending data that helps scientists understand conditions far beyond our solar system. The mission also highlights the importance of global collaboration in space exploration. Explorer 1's journey has been a collective effort involving multiple nations and organizations, demonstrating how international cooperation can lead to extraordinary achievements. The shared goal of understanding the universe has united scientists and engineers worldwide, emphasizing the unifying power of space exploration. Another significant aspect of Explorer 1's mission is its contribution to astronomy. The data it has collected has refined models of the solar system's outer regions and provided valuable information about magnetic fields and plasma waves in interstellar space. These contributions have advanced our understanding of space physics and influenced subsequent missions and research. Explorer 1's continued operation also illustrates the potential for spacecraft to function autonomously. Given the immense distance from Earth, commands and updates must be precisely crafted and transmitted with great accuracy. The spacecraft's ability to conduct scientific experiments and adjust its instruments without direct human intervention is a testament to the advanced software and autonomous systems developed by NASA. Beyond its scientific achievements, Explorer 1 has become a symbol of human perseverance and exploration. Its journey represents the spirit of discovery and the quest to understand our place in the universe. The spacecraft's story has inspired countless individuals and has become a source of fascination worldwide. Explorer 1's mission has also sparked meaningful discussions about the future of space exploration. As technology continues to evolve, there is an ongoing debate about how we should approach the exploration of distant worlds and the search for extraterrestrial life. Explorer 1's legacy serves as a foundation for future missions and helps shape the direction of space exploration in the coming decades. Looking ahead, scientists and engineers are considering new strategies for deep space exploration, including advanced propulsion systems and more sophisticated instruments. The lessons learned from Explorer 1's mission will be invaluable in developing these future endeavors and tackling the challenges of exploring the far reaches of space. Explorer 1's journey is a testament to human creativity, resilience, and the insatiable curiosity that fuels our pursuit of knowledge. As it continues its voyage through the vastness of interstellar space, it stands as a symbol of our enduring quest to explore the unknown and understand the universe beyond our home planet. The team had to proceed cautiously, working with outdated technology to avoid causing additional problems while attempting to resolve the issue. They needed to evaluate the spacecraft's current systems to determine what might have gone wrong. Engineers hypothesized that the problem might lie in the spacecraft's Attitude Articulation and Control System, AACS, which is responsible for keeping Voyager 1's antenna precisely aimed at Earth. If this system malfunctioned, it could lead to incomplete or garbled data transmission, adding to the complexity of the situation. Miscommunication between Voyager 1 and Earth could have serious consequences for the mission. Despite the challenge, the team was determined to address the issue and restore Voyager 1's operations, showcasing the resilience and dedication that have characterized the mission for nearly 50 years. Fixing Voyager 1 from a distance of 14 billion miles is a monumental task. It takes more than 20 hours for a signal to reach the spacecraft and another 20 hours for a response to come back. This means each command must be flawless, as any mistake could take days to correct. After extensive analysis, engineers discovered that Voyager 1 had switched to a backup computer system that hadn't been used since pre-launch testing in the 1970s. This unexpected switch was likely causing the jumbled messages, but the reason for the switch remained unclear. Switching Voyager 1 back to its primary computer was an enormous challenge, demanding the highest levels of skill, precision, and patience from the NASA team. The spacecraft, launched in 1977, was returning confusing data that indicated a problem with its computer system. Specifically, it was not operating on its primary computer as it should have been. NASA's engineers faced the task of switching Voyager 1 back to its main system, which required both technical ingenuity and a deep understanding of the spacecraft's complex systems. They first had to develop a flawless set of commands to perform the switch, a difficult task given that Voyager 1 was designed and built decades ago with technology considered outdated by today's standards. Yet, it remains a highly sophisticated machine, and any programming error could have severe consequences for the mission. The engineers needed to ensure the commands would guide Voyager 1 back to its primary computer without disrupting its other functions. Each instruction had to be carefully coded and checked to ensure it would achieve the desired result without introducing new issues. Once the command set was completed, the team moved on to testing. Testing was a critical step in any complex operation like this. Before sending commands to Voyager 1, the team needed to simulate the process on Earth. This involved using test models and conducting extensive diagnostics to ensure everything would work as planned. Although Voyager 1 is in the farthest reaches of our solar system, beyond the influence of any planet, it remains connected to Earth through radio transmissions. However, these signals take a long time to travel back and forth, with the spacecraft currently more than 14.5 billion miles from Earth. Every communication with it requires almost 2 days for a round trip, so the team couldn't afford any mistakes. There would be no room for trial and error. After successfully testing the commands on Earth, the team sent them to Voyager 1. Then the waiting began. It would take almost 36 hours for the commands to reach the spacecraft, and even then, the team wouldn't know if the switch was successful until they received confirmation. This long delay, due to Voyager 1's incredible distance from Earth, added another layer of complexity to the operation. Each moment was filled with tension as the team awaited a response. When the signal finally returned, it indicated that Voyager 1 had successfully switched back to its primary computer system. This was a huge relief for NASA. The confusing messages from the spacecraft ceased, and Voyager 1 resumed normal operations. This achievement was not only a testament to the NASA team's skill and commitment, but also a reminder of the Voyager mission's remarkable durability. Even after more than 40 years in space, the spacecraft continues to operate and send back valuable data from the far reaches of our solar system. Switching Voyager 1 back to its primary computer was a complex and challenging task that required an ideal blend of technical expertise.